Today in section 1.2 we move on to algebraic expressions, and we have a few terms to go over before we start doing some actual math work. The first one is a variable, and a variable is a letter or a symbol that is used to represent one or more numbers. A common variable that we use is x, but you'll see a lot of different ones, a, b, c, y, z. There's a lot of variables that people will use in various situations. Next, the definition of an algebraic expression is that it's an expression that contains one or more variables. And an expression is not an equation. It will not have an equal sign in it, but it can have addition, it can have subtraction, multiplication, any of those things. But an algebraic expression is one that also has one or more variables in it. Another important term that we need to know is when we have in the directions the term evaluate. And it's important to remember that to evaluate something simply means that we're going to find the value of it. So if you evaluate 3 plus 5, the value of that is 8. You want to simplify it and find a number that represents that expression. So now you can see for our first example, we are told to evaluate a minus 2b plus ab. Now we can't evaluate that unless they give us this second part, that a is 3 and b is -1. So what we do then is we replace every a with a 3. So we're going to have 3 minus 2 times, and we're replacing the b's with -1s. So -1, and then plus a, which is 3, times b, which is -1. So once we have that written out, we simply follow our order of operations. And the only thing going on here is we have addition, subtraction, and multiplication. So we're going to do multiplication first from left to right. We'll do those two first. So we still have 3 minus -2 plus -3. Now in algebra most of the time we want to just get rid of subtraction, so we're going to change this to, instead of subtracting -2, remember you add the opposite, so this will be plus 2 plus -3. So 3 plus 2, we add that, we get 5, plus -3, and 5 plus -3 is 2. So we find out that our solution to this problem is 2. That is the value when we evaluate. Our next example, and I realize now that I had some instructions here for us, but here's the example we have. The first thing we want to do is replace the variables with their corresponding numbers. So negative x is 3, so -3 squared minus 2 times 3, that's the x, plus 1. Again, in this case, once we get there, we're going to simplify, which means just to follow the order of operations. So here we have grouping symbols, parentheses. We're going to do that first. So this will be -3 squared minus 2 times 3 plus 1 is 4. After that, we have exponents to work with. So -3 squared is 9 minus 2 times 4. Then we have multiplication. So -9 minus 8. And again, if you're good at subtracting, that's fine. Or you can think of this as -9 plus -8, which gives you -17 as your answer for that one. So again, that is the value when we evaluate. Now when we simplify, that's different. Simplifying, there can still be variables. There will possibly be some numbers. But when we look at this, we have some terms again. And the first term we have is term. A term in algebra is a number, a variable, or a product of a number and one or more variables. The coefficient of a term is the number part, or it's the numerical factor in a term. Let's do an example of that first. A term, some examples of terms: 3x, 5 is a term, 6ab squared is a term. Okay, and then for each of those, the coefficient would be the 3, or the 5, or the 6. The number part of that factor, or the number factor, is the coefficient. Like terms are terms in which the variable parts are identical, or that they can be written identically. Some examples: 3x squared y is a like term with -2 xyx. They don't necessarily look the same, but if you simplify this one, notice that it is actually x squared y also. But the variable part has to be identical. You could also have 5yx squared. Remember that multiplication is commutative. You can switch that around. So all those variable parts are identical. Some properties to look at. We've got the definition of subtraction, and we just talked about that. A minus b, instead of subtracting, a lot of times we will add the opposite of b. Now remember that negative in front of the b, we want to think about that as the opposite of b. Next, the definition of division. A divided by b, instead of dividing, a lot of times we will multiply by the reciprocal. Remember, algebraically, that's our definition, or that's how we write the reciprocal of b. Now when you take a times 1 over b, notice when you simplify that, you get just a over b. Which would make sense because we know that division line means division. So the distributive property also works for subtraction. We distribute the a to the b, and then we also distribute the a to the c. So we're left with ab minus ac. Multiplication by 0. This is your favorite one. You multiply by 0, and the answer is always 0. Multiplication by -1. If you take any number and multiply by -1, the answer is its opposite. The opposite of a sum. This is basically just a special case of the distributive property, because this negative distributes to the a, and then the negative distributes to the b, so we have the opposite of a plus the opposite of b. The opposite of a difference, same idea. The negative distributes to the a, the negative distributes to the negative b, and you get -a plus b. Now, when you have the opposite of a product, you have to be careful here. You cannot distribute when you're dealing with a product. So that negative can either go with the a, or it can go with the b, or it can be outside in the front of the entire number. It can't go with both of them, because if you put it with both of them, you're going to actually change that value to a positive. And then when we have the opposite of an opposite, so you've got the opposite of a makes it back into a. So when we simplify this, I'm going to show you this one time, and then I probably won't show it this way again. But what we can do is notice each of these terms has a k in it. We can factor out the k. What's left? Well, here, when we take out the k, you've got a 3 left over. Minus, when you take out the k here, remember when you factor out, you're actually dividing. So k divided by k is 1. So we have k times 3 minus 1. Well, if we simplify in the parentheses, that's a 2. So k times 2 is simply 2k. We write the number in the front. Now, we should understand that when there are like terms, the variable part is identical. All we have to do is add or subtract the coefficients. So let's simplify this one with that in mind. So first of all, we have 5z squared. we have to check, are there any other z squareds here? And we have one right here. So I'm going to put those together, 5z squared minus 8z squared. And then we've got minus 10z. And so are there any other z's? Well, there's one more z right there, plus z. So now when we actually combine these, you've got 5z squared minus 8z squared. You combine the coefficients and you get negative 3z squared. Notice the variable part does not change. They have to be the same to combine them, and it doesn't change in the answer. Here we have negative 10 plus, there's automatically a 1 in front of that. So negative 10 plus 1 is negative 9, and we have to keep the z. So negative 3z squared minus 9z is our answer on that one. Now to simplify this, we've got some distributing to do. So first of all, this negative distributes to the m. It also distributes to the n. The 2 distributes to the m. Oops, 2m. And then the 2 distributes to the negative 3n. So negative 6n when you multiply that. Because 2 times negative 3 is negative 6. So now, again, we'll combine the like terms. Negative m can be combined with 2m. Negative n can be combined with negative 6n. Remember that there's automatically a 1 in front of that m, so negative 1 plus 2 is 1m. And again, this is a negative 1 minus 6 is negative 7n. So to simplify that a little bit, we don't usually write the 1, so it's just m minus 7n. And for this one, again, let's just check our like terms. We've got x squared, another x squared, and finally another x squared. So let's add the coefficients. 2 minus 4 minus 1. 2 minus 4 is negative 2, minus 1 more is negative 3, and we keep that x squared. Then if we look at this one, we've got x and x. So once again, we add the coefficients. We've got a 5, and remember this is a 1. So 5 plus 1 is 6, and we keep that x. So negative 3x squared plus 6x. The assignment that I'd like you guys to take a look at tomorrow during class are these problems. 1 through 4, numbers 9, 10, 21, 24, 27, and 33.